Okay, friends, so here's another similar spreadsheet to the ones we've looked at already. Actually, if you want, you can play along. This spreadsheet is available for you right next to the videos. It's experiment number 3, and then we're going to deal until we get a repeated suit. Okay, so it's the same exact idea as the previous spreadsheets. We're going to let Excel do the simulation on this experiment. So every time I press the F9 button, I get a new one. That one, it went hearts, diamonds, hearts. This one was actually a lot of fun to program to get the little symbols in there. It's kind of fun. Here it took 4. It went spades, diamonds, hearts, spades. Here it went 3, diamonds, spades, diamonds, and so forth. Hopefully you're noticing the smallest number is 2. It could be that the first 2 cards that come out are the same suit. This is an example of the absolute longest. You could get one of each, and then the 5th one has to match one of the ones that came before. So what I'm going to do again is I'm going to go ahead and let Excel generate a whole lot of data by holding down this F9 button. And then we're going to look at the resulting data and try to see what's the average number of cards it takes until you get a repeat. So let's let it go for a while. Okay, friends, it doesn't matter where you stop so long as you get some trials in. The math we're about to do in Excel can be done on as few as 1 trial or as many as you want. So we're going to do 2 things now. We're going to figure out the weighted average of our data, like we did before. And then we're going to graph this data with a nice bar chart to give a nice visual of what's going on with the data. It's a nice, very dynamic way of kind of looking at it. And also, what's cool about the bar graph is, or the bar chart, you can see where the average is. And we'll talk about that in a second. All right, so as far as the average goes, we're going to do it the same way we did last time. We're going to add a column. I'm going to call this cards times frequency. Okay, I'm going to make it pretty. Cards times frequency, underline. And then I'm going to use that same formula that I did before, where it's equals, and then I'm going to take the number, the data number, times the frequency of that data number, and then press enter. And you'll notice that when you do that, the data updates, because every time you type something new in Excel with a randomizer like this, it re-randomizes every time. Now I'm going to copy that formula down. And what's kind of cool is you might notice we didn't have to use this column here. We just made the formula span right across. And then you can keep randomizing and the formulas will just keep updating, which is totally, totally cool. All right. I'm going to once again sum all of these results, just like we did last time. So Excel has dealt about 37,000 cards in this case. So quite a few cards. Let's add a few more just because I'm feeling saucy. And then what we're going to do, just like we did before, we're going to type the word average. And then we're going to use the formula that we did before, which was equals that number divided by that number. Now, when I say that number and that number, it's the total number of cards dealt divided by the total number of trials in our experiment, which gives us a whopping, 3.2696. Let's take a few of those decimals off. We don't need that many decimals. That's just ridiculous. We call it 3.3, and we'll let it randomize, and you'll notice it's pretty much stabilized at 3.3. Maybe if you give it one more decimal, you got a little bit of wiggle. I know when we stopped it was 3.26. Looks like even 2 decimals, maybe at 3. Oh, it's okay. It's moving a little bit at the 3rd decimal, but we're definitely stabilized at the 1st decimal, no matter how many times we're running this trial. So it looks like the average takes a little bit more than 3 cards before you see a repeated suit. So 3 is not quite enough. 4 is too many. The average is in between, a little closer to 3. Now, that was an interesting statement. 3 is not enough. 4 is too much. The average is in between, closer to 3. I want to look at a visual of that, because you can actually see averages on bar graphs. So I'm going to show you all how to make a bar graph off of your data right now. The data, if you remember, is here, but the frequencies are here. So you've got 2 dimensions, just like we talked about a couple weeks ago with statistics. So we're going to want this on the horizontal and this on the vertical. The best way I've found to graph this kind of stuff in Excel is to select these first, then go to Insert, then go to the bar graph option, and then just drop it in. And that right there, my awesome friends, that is, or these frequencies right here, graphed. Now, if you randomize, they don't move a whole lot because, well, they are moving. They're just not moving a whole lot because these numbers are so large and it starts at 0 and goes up. Don't worry about that. We'll deal with that in a second. The bigger problem I see is that, well, number one, the chart title is kind of lame. Let's fix that. Let's see. How many cards until we get a repeat? I spelled some of that wrong. There we go. Repeat. All right. That's not bad. It's not a bad title. I don't see any axis titles. Let's add those. This is going to be cards dealt per trial. And then this, I'm going to call this is a general frequency. Those of you going on to stats will incorporate, or you'll encounter the word for, ooh, maybe spelled correctly though, frequency. You'll experience that word quite a bit. It's a big idea in statistics, how often something happens, the frequency with which something happens. Now, the one thing that bugs me about Excel, and this is one of the things you have to get used to if you're using Excel, is the fact that these numbers down here are wrong. You don't deal 1, 2, 3, or 4 cards. You deal 2, 3, 4, or 5 cards. So easy fix. It's a little button pushy, but it's easy. You right-click on the graph, go to Select Data, and then edit it. And then for the axis label range, just select the ones you want, and then it'll drop them in right there. You see them now. There they are right there. I'm going to make them a little bit bigger and bolder so we can stand out a little. That's not bad. That is not bad at all. Okay, now I'm going to show you a couple little things that I do with the graphs to clean them up a little bit. I'm going to tell you this one right now. I don't, with bar graphs, especially ones that are dynamic like this, I don't usually use a frequency axis. I delete that, which is bad. Like that graph by itself is terrible. But what I do is I right click on the bars and then I add the data labels. So what you see now is the actual numbers as they're changing, updating on the graph. I kind of like that. That's my personal opinion. You don't have to do that if you don't want to. I just think that's a nice look. I like it for a couple of reasons. Number one, the dynamism of the spreadsheet gets to shine. Right? Because as they're changing, that you see the changes here. That's kind of sweet, where you couldn't really see the bars moving that much before. That's one thing. The other reason is it's a little more artistic, is it focuses more on this. There's not that weird word and vertical axis over here. So, I don't know, just something I think about when I'm designing graphs for public consumption. The only other thing I would change, and I'm going to make the graph a little bit skinnier here, is these bars are kind of narrow. So I right click on them and then format them. And then I goof with the gap width. So you can actually make the gap narrower between the bars. And I kind of like that, the way that one looks right there personally. That's kind of a good looking bar graph. You can go right crazy with this stuff. You can change the colors, you can change them to gradients or textures. I mean, there's all kinds of stuff you can do. I'll let you run with that. There's no reason to get into that. But what's so cool about this is you now have a visual. And the last thing I want to talk about is, again, this average that we calculated over here, which is pretty rad. The average number of cards is 3.3. A way to visualize the average. I want you to imagine this as a tray of cookies, where you've got 3,107 cookies above the number 2, 4,796 cookies above 3, 3,857 above 4, and 1,390 above 5. And I want you to envision where you'd have to put your finger on this tray to balance it. So if you had to put your finger along one point on this horizontal axis, where would you put your finger to balance it? Well, it's pretty clear that if you tried to put your finger right here directly between 3 and 4, the tray would fall to that side because there's more stuff in these 2 bars than these 2 bars. So you'd have to move a little bit closer to 3. But if you moved all the way to 3 and split the difference here, you then have too much weight on this side, so the tray would fall back. So the question, where do you put your finger to balance it? You put it at 3.3. So you go about a third of the way from 3 over, And when you're there, you have taken the graph and you've sliced it in such a way that you've placed an even weight of the left and right sides and even distance away from the average. Hopefully that makes sense. I hope that makes sense. I think this is a good place for us to stop and put some of this to use in some other experiments.